In this video I'm going to look at how we can identify within a set of spectra in a VAMAS file which data have been processed in some respect, peak models, regions, or actual processing such as calibration. And the way you do this is using these three new toolbar buttons. So these data here, as you can see, the Carbon 1s certainly have a peak model defined. These are displayed in the active tile, and these are all overlaid, so every one of these has a peak model on it. The other data, the nitrogen, there's nothing on this. Oxygen, nothing on this. The only other spectrum with some processing in the sense of regions are defined on this survey measurement. The other survey measurements are without regions. So we only really have the carbon and this one survey measurement at this point where there's some sort of processing in terms of peak models, regions, and we can see which ones have the peak models if we use this button here that says select blocks with components, and there it is. We can see that we've got the Carbon 1s. Now we can select the blocks with regions, and this will include the survey measurement because this had regions defined. You can see these three regions, and that's the reason that that was highlighted at the same time as the Carbon 1s. Carbon 1s had regions because of the peak model, so these are the only VAMAS blocks with either regions or, in this case, components. Now the next question is there any processing such as calibration on these data? And the answer is yes. All of these have been calibrated. So if we look at the history, you can see that there are calibration statements indicating we've got some processing on these data. So these three buttons here are very useful when we want to work out what it was that we last did on data. For example, in this set of spectra, we may have defined a region on one of these nitrogen spectra. So let's put a region that we can recognize, and then we go and look at some other data and we want to say, oh, I wonder which one it was that we analyzed with the region, and so we can then recover the information about which ones have regions, and that's the one that I was working on. So that's the function of these display modes of the selection, and they can be very useful if we want to just check that we still have the calibration on all the data, so that we now know that we've done the calibration for all the data based on, in this case, the Carbon 1s spectra. So I've aligned the Carbon 1s spectra on the basis of one of the components in the peak model, and that would allow me to do something such as rebinning, and then I've got a rebin file created where the calibration has now been folded into the data. We're interpolating intensities for the different nodes of the binding energy scale. Means that we now have data pins and intensities that all are in a state that we can sum. I can see that there's no processing on these data, and that's because it's been folded in to the raw data, so there's no processing history. The calibration is now part of the data itself. It's within the raw data for these VAMAS blocks in the rebinned file, and that means that when I select, let's say, only the narrow scan spectra, if I wish to sum these rebin data, I can use the sum columns and produce a new VAMAS file which hopefully is produced better signal to noise and without damaging the resolution, because I've rebinned the signal to the data pins that are all corresponding to one another. Hence the spectra should be better signal to noise and easier to see that we've got a step, for example, in this nitrogen background.